In this lesson, we're going to tell if an equation or a graph shows direct variation. How will we know if a graph shows direct variation? Well, another word for direct variation is proportional. A line will show direct variation, or it will be proportional, if it is straight and it passes through the origin. The y-intercept is 0. It doesn't matter if the line is a positive slope or if it's a negative slope. It just needs to be straight and it needs to go through the origin. So how will we know if an equation is showing direct variation or if it's proportional? Well, it will be in the form of y is equal to kx, where k is the slope, the constant rate of change. You'll also see it written as y is equal to ax, where a represents the slope or the constant rate of change. So let's figure out where we get this equation. If we have the equation y is equal to mx plus b in slope-intercept form, remember the b, or the m represents the slope, and the b is a y-intercept. So basically, the direct variation equation is this part of it, because b is actually going to be equal to 0 because it's going through the origin. So let's take a look at each of these graphs and determine if they represent direct variation or if they're proportional. All right, so the first one, remember, it has to go through the origin and it has to be straight. So the first one does show direct variation, or it's proportional. The second one, it goes through the origin, but it's not a straight line, so no, it does not show direct variation. The third one, well, it's a straight line, but it does not go through the origin, so that one is no, it does not represent direct variation. Our fourth one, well, yeah, it goes through the origin, and so if I were to extend this line would keep going this way. So yes, this one shows direct variation. Number 5, well, it's kind of a straight line, but it does bend, and it goes through the origin, but no, because it's not just a continuous line that goes straight, the answer to that is no. And our last one is yes, this one shows direct variation because it goes through the origin and it is a straight line. So tell whether the equation represents direct variation. Remember the direct variation equation, it's y is equal to kx, or I also like to just say y is equal to the mx because you don't have the plus b in the slope-intercept form. So let's take a look. Well, y is equal to 2x. Yes, it's in this form up here. Y is equal to 4. Well, y is equal to, I don't have a slope there. I don't have a constant rate of change with the x, so no. And if I were to graph this, this would be graphed looking like this. It'd be going up through the 4, and I don't go through the origin. If I went back and I graphed this one, I would be going y is equal to 2x. It would be graphed because I can, if I don't have that there, I can say plus 0. And notice then I go up 2 over 2, I would have a graph then that went through the origin. My next one, y is equal to 2x plus 4. Well, I've got this part of it, but I've got this plus 4, and that plus 4 is going to have it go through the y-intercept at the 4. And so this is going to be no. It's going to be a straight line. But so take a look here. Remember, if I were to graph this, I'd go up 4, and then I have a slope of up 2 over 2. And so I've got that straight line, but since it doesn't go through the origin, it is no. Y is equal to x minus 5. And again, no, because if I were to graph this, notice that I would start down here at the negative 5 at the y-intercept, and then I'd go up at a slope of 1 all over 1. So it would look like this. So no, because it doesn't go through the origin, it's not. My next one, xy is equal to 4. No, that's not going to. So our number 6, let's go ahead and I'm going to solve for y. And y is going to be equal to 8. And in this case, no, because It doesn't have that x, the slope. So what this would look like if I graphed it is I would have it just go through up at the 8, and it would go this way, not making a straight line that goes through the origin. Let's go ahead and explore a graph that shows direct variation. Find the constant rate of change for the linear function. Remember, the constant rate of change is the y all over the x is going to be equal to k. Y all over x is equal to k. It's the rise all over run, that rate of change. So if we take a look starting right here, and if I go up 120, the change in the y all over the change in the x, I'm going to have a constant rate of change of 60. All right, so determine whether a proportional linear relationship exists. Well, taking a look at our graph, it goes through the origin and it forms a straight line. So yes, this is a proportional relationship. And now write an equation that relates the number of shares in the total cost. Remember, another form of direct variation is y is equal to kx. And so in this case, we said that k is equal to 60, so y is equal to 60x. That's going to be our equation.